Hello, guys. In this video, we're going to be reviewing the 303 quiz on graphing lines. And this quiz contains information about graphing linear equations, writing the equation given a line, and finding your x and y intercepts. All right, so first, let's talk about one that is similar to question number 1 on your quiz, which is solving and finding x and y intercepts. In this question, we are asked to find the x and y intercepts of the line negative 7x minus y equals 14. First off, we need to refresh our memory and remember that when we're dealing with an x-intercept, the definition of an x-intercept, what an x-intercept is it is a point that intercepts your x-axis, meaning it is on the x-axis of our graph. So if we just draw kind of a silly little graph in the corner, all right, your x-axis is the horizontal and the y-axis is the vertical. So if we have an ordered pair, if we have an x-intercept, it's lying on that x-axis, meaning that for an x-intercept, in order for it to remain on the x-axis, your ordered pair is some number for x. So you move along that x-axis, but then your y value will always be 0 because that's what's keeping it on the x-axis is you're not going anywhere vertically. You're not going anywhere along the y. With that information in mind, we can use that plus our equation to find the x-intercept. In order for it to be an x-intercept, your y value has to be 0. We can substitute 0 into our equation for y, and that will allow us to find the matching x. We take our equation here, negative 7x, but instead of minus y, we are going to substitute a 0 in for y, so we can find when y is 0, what does x equal? Once that is done, we simplify and solve our equation like normal. So negative 7x minus 0, I don't really need to write that because if you subtract 0, it doesn't change it at all. Negative 7x equals 14. To solve that equation, it's negative 7 times x. The inverse of multiplication is division. Negative 7 divided by negative 7 is 1. We're left with 1x. 14 divided by negative 7 would be a negative 2. When your y value is 0, for this line, for this equation, your x value is negative 2, meaning our x-intercept is the ordered pair, negative 2, 0. And I'm going to be estimating here, but that on this line would be approximately right here, negative 2, 0. We're going to do a very similar thing for your y-intercept, only the opposite is true. If it's a y-intercept, it's on the y-axis. That means in order for that point to stay on the y-axis, we don't go anywhere along the x. We only move vertically along your y. So that ordered pair will always have a 0 for x and then some number for y. So this time we're going to use our equation and we're going to substitute. We're going to plug in 0 for x so we can find what the y value would be. We have negative 7, but instead of negative 7 times x, we're substituting that 0 in, it would be negative 7 times 0. Let's simplify and solve. I need to simplify here and do that multiplication. Negative 7 times 0 is 0. We're left with negative y equals 14. What is that negative y really? It's really a negative 1. We will divide both sides by negative 1, and our y-intercept is negative 14. So when x is 0, y is negative 14. So our y-intercept is 0, negative 14. And again, I'm just estimating here on that graph, so that would be somewhere down here. And if you were asked to graph it, in this case you won't be, but you would then, oh yikes, that line is way off. Let's move that over. You would then graph your line. And since it is a line and not a line segment, make sure you have arrows on both ends. All right. Now, question 2 and 4 on your quiz are giving you a graph and asking you to write the equation of the line. In both of these instances, we are asking you to write the equation of the line in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. And in that equation, your b is representing the beginning of the graph, your y-intercept, and your m is your movement. So that is your slope. And your slope is that change in y over your change in x. You also may see that referred to as your rise over your run. If we want to write the equation of the line in slope-intercept form, the two pieces of information we need are the slope and the y-intercept. That's why it's called slope-intercept form. First off, when I look at this graph, I'm going to find that y-intercept, all right? Because that's the first thing I do when I graph it. I'm going to kind of be a creature of habit and make that be the first thing I find when I do the reverse and write the equation. Well, our y-intercept is where our line intercepts, crosses our y-axis, which would be this point right here. And if we notice, our graph is technically counting by ones, just every other line is labeled. So this would be -1, -2, -3. Our y-intercept is -3. Now, to find that slope, remember your slope is a movement. It is that rate of change. Slope has a lot of synonyms: rate of change, constant proportionality, rise over run. But in order to do any of that, we need a second point on the graph. We can choose any point we want as long as it has an exact value. No estimating here. If I look at my graph, I notice that right here is a nice point, the ordered pair 4, -4. There's no estimating. So I'm going to use my y-intercept in that point to calculate my slope, to calculate that change in y over change in x. I'm going to go from left to right because that's how you read a graph. If I start at my y-intercept, I have to decrease 1. So our change in y, because I'm decreasing, is a -1. Then our change in x, I go over 1, 2, 3, 4. Our change in x, and I went to the right, making it a +4. The slope of this line is -1 over 4. Great, that is all I need, because when we write the equation of the line, the x and the y represents all of those points along the line. So we're going to keep it generic. We're going to keep the y and the x as a variable. Now substitute these into my equation and we have our answer. Our equation, y equals mx plus b. Y equals m, the slope of this line is a -1/4. X, in this case, our y-intercept is a -3, you can either write plus a -3 or you can simply write -3. And there we have an equation that matches this line. Question 3 is the reverse of that. You're given an equation and we need to graph it. This equation that we're given is given to us in slope-intercept form. The first thing that we want to do is identify that slope and the y-intercept. If that's something that you're still, working on getting good at, my recommendation to you is to always write the formula, the generic one, above your problem. And then it makes it a lot easier to see where your M lines up and your B lines up. So we have y equals m x. Oops, I meant to change colors there because your m is just the coefficient. It does not technically include the x, plus b. Our very first step is to identify that information. What is our m in this case? What is the slope? It would be a -1. Notice that they're lined up right on top of each other. That's the coefficient of your x. Our slope is 1. What is the b? What is the y-intercept? It's a +3. Always look at the sign. And in this case, it's a +3, otherwise known as a +3. All right, now that we found that information, that's actually all we need to graph. That will give us what we need to create a line. First, we're going to start with our B, the beginning of our graph. That is a y-intercept of 3, meaning as an ordered pair, it would look like this. So be very careful, guys, to make sure when you graph that, you put it as a y-intercept and not accidentally as an x, because your B is your y-intercept. So 0, 3, that is our starting point. Now our slope, that m is a movement, m for movement. So it's not that I have the point -1, that's my slope, that's my rate of change. So I'm going to move that slope, and that will create a second point on my graph, allowing me to have a line. With slope, though, our slope is always our change in y over our change in x. So in this case, fractions are your BFF when it comes to slope. If you have a number that's not a fraction, you're going to make it 1 because you need your slope to be a fraction. How can we make any number a fraction? By putting it over 1. So the equivalent form, the fraction form of -1 would be -1 over 1. All right. Now, when we do that slope, when we do that movement, it's not an ordered pair. So I don't start at the origin. I start at my y-intercept. That's where my graph began. So from that point, we're going to do a change in y of -1, meaning we go down -1. That's our rise, our change in y. And then our change in x is a +1. So we're going to go right 1 because that follows that x-axis, your change in x. And that creates our second point. If we wanted to do it again, just to verify, we could. We could go, our change in y is down 1. Our change in x is right 1, and we have another point. I like doing that whenever I can because seeing that third point helps ensure that we really do have a nice straight line. But I know typically IXLs and online quizzes just have you do 2 points. Because we had to graph a line, we better connect those points and actually make it a line. All right. I believe we have one more. All right, question 5, it's the end of the quiz, kind of amps it up a little bit. It asks you to analyze an equation of a line. Select, in this case, all of the true statements. All right, Mrs. Elstack graphs the equation y equals 2/3 x minus 7. Select all of the statements about Mrs. Elstack's graph that are true. I'm just going to go through these one by one and test them out. First off, the graph is a curved line. Nope. This right here, slope-intercept form, y equals mx plus b, that is the equation of a linear equation. Linear line, meaning it will be a straight line. So it's not curved. Not going to check that one off. Option 2, the graph is a straight line. Yeah, we kind of just discussed that. So that would be an answer. The graph goes through the origin. All right, well, the origin is the center of your graph. We can do a sketch of the graph to kind of help us verify. There's more than one way you can solve this, and I'll show you both. But one is we can just do a simple sketch of the line. All right, if I were to graph this, my y-intercept is my b, my -7, so I'd be starting down here. And then if my slope is a 2/3, is that increasing or decreasing? That's increasing. And if I start way down at -7 and I increase by 2 to 3, that's going to be somewhere over here. And is that going to pass through the origin? No, it's not. All right, let's do it a different way to verify that it's really correct, because, you know, sketching a graph gives us a good estimate, but it's a sketch. It may not be 100%. You know how earlier I talked about how when we write that equation of the line, we keep the y and the x a variable because it represents your x and y values, your ordered pairs along the line. Well, sometimes when we're testing things, we're going to actually make them a number. What is the ordered pair for our origin? 0, 0. Our origin, let's choose just 2 different colors here. So our origin is the ordered pair 0, 0. If we want to test that, if we want to see if our line goes through that point, I can substitute that point into my x and y values and see whether or not it works for the equation. All right, our equation, let's write it up above so everything's lined up. Y equals 2/3 x minus 7. I'm actually going to color code my x and my y. In case you hadn't noticed, I love using colored pencils. I love using color in math. I think it helps everything stand out beautifully. So if you guys have colored pencils, I'd encourage you to do that too. All right, we're going to substitute that ordered pair in for our x and y and see if we get a true statement, see if it works. All right, our y is 0. And then this is 2/3 times our x, and because it's the origin, that's also 0, minus 7. Take note here that because I've substituted, do I have any more variables? No, I don't, meaning that we are not really solving our equation, we're just simplifying. If I look at the left, where I have my red 0, I don't have any simplifying, it's just a plain 0. All of my focus is going to be simplifying on the right side. I have 2/3 times 0 minus 7. We follow order of operations. Multiplication and division comes before addition and subtraction. 2/3 times 0 is 0, meaning we're left with 0 minus 7, otherwise known as minus or a -7. Is that a true statement? Is 0 equal to -7? Heck no, it's not. That's false. Because that's a false statement, that means the origin is not included on our line. If it worked and we got a true statement, then that point would fall on our line. It didn't work, so we just verified that our sketch, our estimate was accurate, and that point is not on the line. So I'm not going to check that one off. Fourth option, the y-intercept of the line is 7. Hopefully you read that carefully and don't get tricked, because it is false. What is the y-intercept of our line? A -7, a -7. But that says positive, so it's false, not true. And the last one, the slope of the line is 2/3. Yep, the sign matches, our slope is our m. Therefore, those are the only two true statements. All right, I hope this helps you guys. And if you have any other questions, send me an email, come to a help session, and I'll be happy to assist. Bye.